So we're back with this thing. I just want to continue just explaining the code at the end. But the last bit of the code is really not about testing. Sorry, it's not really about reading from the controller. It's more about how I displayed things. And it's getting late, so I'm going to yawn. So the trick here. So on the last video, I just quickly said that the select pin is an output pin, but also these digit 1, digit 2, digit 4, and digit 8 pins are also all outputs. So these all start at 2, so this is 2, 3, 4, and 5 on the Arduino. This is absolutely not needed at all. That was just the testing code, so you can get rid of that. In fact, you can get rid of that as well. So we can cross those bits out. That won't make any difference. You don't need the serial stuff anymore. It's all tested and functions fine. So we're basically setting all of these things. So I didn't use the for loop for this because it's just set as being 4 different pins, and I couldn't be bothered doing any really clever general thing. It's not like I'm ever going to get like a 7-segment controller thing that actually has 5 bits and goes all the way up to 30 or something. So down here we've got set digit, and actually, I mean, I could have made this a bit more general, couldn't I? I could have passed in the very first pin. Doesn't matter. Anyway, so this is I've done this in 2 ways. One of them is the sort of slightly naive way, and the other one, which is this one here, is the slightly more advanced way. So here, all I've done is using Boolean logic. That's the right word. It is the right word here. To extract out each individual. But I'm actually surprised this works. So okay, in the world of C, a 0 is basically what false is. So if you say if 0, that's false, and if you say if 1, then that's true. So if you say if 1 print hello, then it's going to print hello because 1 equates to true and 0 equates to false. But general, I think, I can double check, but 0 is, it's one of these things that change between different languages, I think. It's been a long time, but this actually works. So I didn't actually think about this when I was doing it, but it works fine. If anything, if 0 is false, but anything else is true. So anytime you have a bit on that's like 1, anywhere within the byte, then that's going to be counted as true. This question mark thing here they're called the trinary operator. So I don't know if I don't think I've used this previously, but basically it's like a simple expression. It has 3 parts to it. The first part is this bit here, which is the conditional. So it's kind of like an if statement. So if this is true, then the value you're actually going to use is going to be the first thing, and if it's false, it's going to be the second thing after the colon. So basically what this is saying is write to digit 1. First off, we do value and 1. So this is a Boolean AND operation. So you'll have to go back to the previous video where I talked about using AND to extract out bits from a number. So if I AND something with 1, so 1 is just in binary 1 0 0 0 0 0 0. It's 0 0 0 0 0 0 1. So it's just 1 with everything else being 0. So this, if you AND things, it's going to extract out the very first bit. In this case here, I'm going to AND it with 1, so I'm going to get the very first bit of that value. And if that first bit is high, is 1, then that's going to evaluate to true, and then we're going to output high. And if it's 0, then we're going to get, this is going to evaluate to false, and we're going to output low. The second thing is going to do value and 2, so this is the second bit in the byte. Remember, we're counting in binary here. So it's going to do exactly the same thing. If the second bit is on, or 1, then we're going to output high to digit for the 2's, and low otherwise. This one is looking at the 4 bit, the 4 digits bit. I don't know if that's the right way. It's the 3rd bit anyhow along. So I can't do this because it's upside down. But I did explain this in a previous video, so should have to go look at that. But basically that's going to be extracting out the third bit going along, and that's extracting out the fourth bit and setting these pins. So this is just going through and setting the pins to high or low depending on whether they're high or low within the actual byte, or they're 0 or 1 within the byte, which is value. So this is a function for just outputting the value onto my LED display. So that's kind of the naive way, even though it's kind of complicated and uses complicated code. And the simpler way, but this way is very sort of, the good thing about this piece of code is it's reasonably general. You could actually change it up a bit and pass in a particular pin that to start from, and then go through and like you could set these to be like 0, 1, 2 and 1, 2 and 3. And then you could have a starting pin, and then you could add that to each of those things, and then you could generalize this function to be so you could have more than one LED display. This one here kind of requires you to have to know which pins exactly you're talking about. So this doesn't refer to any of these constants at all, it just happens to know. And I don't know if I'm going to have time to talk about this, but this is like the introduction to doing this kind of stuff. So here I'm using this variable, which I haven't actually defined at any point before. It's a bit weird. It's all in capitals now that I think about it. But it's a special systems variable, and this one's port D. There's a whole bunch of these variables, and these are like underlying registers within the Arduino that let you directly alter things. So when you actually write digital write, it's going to actually end up doing something with port D here in this particular example, and it's going to go through and it's going to set a particular bit within port D and not change anything else. Here I'm actually going through what am I doing? Alright, this is like a very complicated expression. So don't worry if this doesn't make any sense to you, but this is another way you could do it. So the Arduino's pins, first thing is that they're divided up into various ports, and I've gone and forgotten what port D covers, but you can kind of work it out from what I've done here. So it will start at, let me just work this out, this is going to be pin 2. So port D covers pins 0, 1, 2, 3, 4, 5, 6 and 7. So on here, ports pins 0 to 7 are classified as coming under port D. So there's a data direction register as well for each different port. So some of the ports don't match up exactly with everything. I don't know what they all do. I just happen to know that port D here is for pins 0 to 7. So what I'm doing when I do this bit of code, so the very first step is I am taking the code, the current value of port D, so I'm reading in the value of port D, and then I'm going to, and so I'm assuming everything here is an output, but it might not be. I don't think it matters if you try and write to an input pin. It doesn't seem to have any effect on this, so that's fine. But I'm doing that and I'm ANDing it. So basically when I'm ANDing it with this mask, so since I've got the 1 in the location for pins 0, 1 and 2, 3, 4, 5, 6 and 7, with a 1 there, what I'm doing is I'm trying to keep those values. So I'm reading in the value of port D, I'm ANDing it with this mask here, which will keep the values of each bit where there is a 1. And it will basically convert everything where there's a 0 to 0, because 0 and something else is always 0, or false and something is always false, or low and something is always low. That's what the AND operation means. So the AND is only true when both things are true. So if one of those things is false, then you know that the answer is always false, regardless of what the other part of it is. So this is just the way. Again, this came from the previous video where I went through this, but I think I'll just keep going over it and over it again. This is just to read the current value of port D, convert the values for pin 2 to pin 5 to 0. So I'm clearing those pins. And then I'm going to OR it. So ORing is how I merge things in with what I want. So an AND operation is to remove things that I don't want in this case, and then the OR is to introduce the things that I do want. So I'm taking the value from here, and I'm assuming that it's a value between 0 and 16. This is kind of not going to work if you give it a higher value than 16, or 16 or higher. So if you use more than 4 bits, then you're going to get a funny answer when you try and do this trick. But here I'm shifting it. So this is the shift thing. So I'm taking my value, which is 0, which is the first 4 bits of the number. So I can kind of draw this upside down. So here is my, let's make sure this is actually on the screen. Here is my byte. These are the first 4 bits, and these are the second 4 bits. So a byte has 8 bits in it. And this thing here is going to shift everything 2 bits. So I'm going to move this bun 1 bit, and then another one thing. So this thing here is going to get shifted to here. And it's now going to end up in the middle. So I'm taking the value in the brackets, shifting it 2 bits to that direction, basically so that it's in the middle of the byte. And then I'm going to OR it, which is going to basically merge it with this value here. So this thing here is turning the 4 bits that I'm concerned about to 0. This thing here is taking my input, shifting it so that it lines up with the 4 bits that I've turned to 0. And the OR thing, OR operator, is merging these 2 things together. So an OR operator will always convert something to 1 if either of the inputs are 1. So in this case here, that acts like a merge. So if there's a 1 in this thing here, it will become a 1 over here. So if the first bit of value was 1, then ORing it will make this thing a 1, even though this is a 0, because 0 or 1 is going to be 1. And if the other things that we don't actually know what these values are, they're the old values of port D. If they happen to be 1, then they'll also be 1. And the answer, I'm going to lose my voice. Hold on, I need a drink of water. It's a very, very professional video. And so, that's basically what you end up doing. So this complicated operation just takes the bits from value, shifts them along a bit, clears some space first, and then dumps those values in the middle and keeps the old values for the other pins that we aren't touching to whatever they were when we started. So you're not messing around and with the other outputs if you happen to have any. So that's one little line of code that does all of this, and it will do it a lot faster in a way, because this one here, when you're doing digital write, this whole function here is going to do a whole lot of stuff to try and work out which port you're talking about for which pin. So it's going to say, well, what pin are you talking about? You're talking about this pin. Okay, well then you're talking about port D, and then you're talking about bit number 3, and so then I'm going to have to, do all this funny stuff with masks and all this just to set one of these pins. So it might look like it's only 4 times faster, but it's probably a ton faster than doing it this way. So even though it looks kind of complicated, you get, if you do this stuff enough times, then that's going to be very, very simple. And if you're writing some code that has to be really, really fast, then this is a much better way of doing it than doing it this way. So, and if you're not using the Arduino IDE and you're using like the other stuff, this is how you probably would do it in the first place. And then the very last part, we've got to finish it up, is the actual loop method, which just basically reads in the pin from my read pin stuff, which was from the previous video, sets that digit on the display to that. I also printed out to the serial output. I don't know why I left that line of code in there. But that's why I have a delay of 100 milliseconds. It used to be like 500 milliseconds, so that I don't print out so much stuff on the serial output that it takes forever. But really, I don't need this line at all. And if I got rid of that line, I don't really need that line either. I can just do it as fast as I want. Then I have to get rid of everything else. But that's fine. It's fine actually, just to test it every 10 times a second, and you still get responsive feedback. Is there a joystick next to me? I don't think there is. There usually is, but there isn't. So we can't test it with an Atari joystick. But we can. I've got this one. So I actually thought I broke one, but this one looks like the other one. So maybe I didn't break one. So I'm just going to finish this video by finding out whether or not I actually did manage to break both the controllers. So I've only got 2 of these. So if they both work, then it looks like I'm going to swap them over while it's still running to see if I can break something. Alright, so does this one work? And the answer is no, it doesn't. I did break it. I'm kind of proud of myself. Did I just break it by swapping it over while I was running it? Alright, I'm going to take it out and plug it. Should turn it the right way around for everybody else. No. So that's a bit okay. Unplug it again. I don't like breaking things, but that does answer that question. And plug it back in. Oops, that's not actually the one that I was working. So that one still works fine. I didn't break that one. So the moral of the story is, if you're going to build a joystick tester, build the joystick first, or the joypad tester. So that's sad. I've broken that. Well, we can take this one apart and see maybe with its fake screw if there's any possible way. I doubt this actually uses the dip version of this IC. It probably uses something else entirely. It will have a little blob thing, so I doubt you can fix it. Maybe I could build a controller and put it on the inside of here and just use the buttons. That would be funny. Alright, thanks for watching and see you next time.